Good morning to everyone. I'm Sushma. I'm here to present the presentation on the ANOVA gauge R&R and the process capability studies performed at Metromold and Design. Coming to the introduction part, the organization where we did the project is the Metromold and Design. It was founded in the year 1973. MMD does various kinds of molding. MMD has specialized in the fuel cell manufacturing since 1997, and MMD do also involved in manufacturing of various general manufacturing products like surgical instruments, medical devices, fuel cell manufacturing, printer components, and custom plastic enclosures. The mission of the MMD is to provide the value-added manufacturing services with the creative engineering for the customers with the complex needs. Coming to the objective of the project. Objective of the project is to measure the whether the measuring and the testing systems used by the Metromold and Design is capable of producing the valid results or not. Coming to the scope of the project. The scope of the project is to perform the ANOVA gauge R&R study and to perform the repeatability test by taking in the sample plate and taking 25 readings and plotting the IMR graph, and to plot the X bar and R bar chart, and to conduct a process capability studies. Coming to the next, this is the picture of the operator measuring the monolith plate by using the vernier calipers. Here operator is measuring the x-axis of an monolith plate using the vernier calipers. Data analysis and ANOVA gauge R&R. In this here gauge R&R analysis is done by considering the two factors, they are the part and the operator, and utilizing the 10 parts, 3 trials and 3 operators. Therefore 30 readings for one operator and 90 readings for the 3 operators. Total gauge R&R study is based on the two things. First is the 99% of the confidence interval, and next thing is the percentage of tolerance limit should be less than the 20%. This is a screenshot of the gauge R&R of ANOVA from Minitab. Here we can see the two-way ANOVA table with the interaction, two-way ANOVA table without the interaction, and coming to the values part. Here we consider the p-value, and the if p-value is less than the 0.05, we can't reject the null hypothesis. Here in case of part number, means are equal. In case of operator ID, it is greater than the 0.05. So we can say that operator has no effect. In case of the part number and operator ID also, it is p-value is greater than the 0.05. So there is no interaction between the part number and operator ID. Coming to the next thing, here we are going to describe regarding the percentage contribution. Percentage contribution is nothing but the measurement of the variation, which is nothing but the measurement of the standard deviation, that is nothing but the square root of the variance. And coming to the percentage study variance, percentage study variation is nothing but the comparing the measurement system with the total variation. Total variation, and percentage tolerance is nothing but the comparing the measurement system variation with the tolerance or with the specifications. Here for the percentage tolerance limit, it should be less than the 20%. Here we can see that it is less than the 20%, it is about 17.9. so our measurement system is good. Coming to the number of distinct characteristics. Number of distinct characters is nothing but the estimating the how many separate groups of the part system can distinguish. Here it should be greater than or equal to the 5 for the system to be acceptable. For in our case it is 2, so it is not acceptable. Coming to the gauge R&R graphs. The first is components of variation. Here each cluster bar represents the source of variation. By default, each cluster bar has two bars corresponding to the one is with the percentage contribution, another is the percentage study variations. If you add a tolerance or the standard deviation, a bar of percentage tolerance also appears. And for a good measuring system, the largest component of variation is the part-to-part variation. If instead large variation is attributed to the measuring system, the measurement system may need correcting. In our case, part-to-part variation has a largest variation component, so our measurement system no need of correction, it is good. Coming to the R chart is nothing but the measurement of the control chart of the ranges. Here only the 1 point by the operator 1 is above the upper control limit. It should be within the control limit. Only 1 point is out of the control limits. It is negligible and it is acceptable. Coming to the X bar chart is the one which compares the part-to-part variation to the repeatability component. In this case, many points are above or below the control limits. These results indicate that the part-to-part variation is much greater than the measurement system measurement device variation. And coming to the operator by the coming to the part number and operator ID interaction. Here we can see like lines are virtually identical and operators are measuring the parts similarly. And coming to the length by the operator, here this circle one represents the means, and here asterisk represents the potential outlines, and here line is parallel to the axis. So the operators are measuring the parts similarly on an average. Coming to the results, the percentage of tolerance is less than the 20%, that is 17.19%. So the ANOVA test is passed, and the smaller p value indicates that we can't reject the null hypothesis. So operate has no effect. The part-to-part variation is 70%. It is good. Coming to the repeatability test, we perform the repeatability test by taking the plate randomly from the group of plates and measuring it and taking the 25 readings of that random plate and plotting the minita. We got this graph. It is within the control limits. Here mean is 524.662 and the percentage tolerance is the 5.76. In case of repeatability test, it should be less than the 10%. So for our case, it is 5.76%. So inherent repeatability test has been passed. Coming to the process capability test, process capability is nothing but the measurement. Process capability is nothing but the measurement of the index, which is nothing but the measurement of the process capability index and the process performance index. It should be greater than 1.33. In our case, it is greater than, all the values are greater than 2. So our measurement system is good and it is measured within the two specification limits, lower and upper specification limit. And here we analyze based on the histogram of the graph, and it follows a normal distribution. And CP and CPK value is greater than 2, which is good because it should be greater than 1.33, and PPK value produces an index number for the process variation. So the CPK references the variations to your specification limits. Coming to the X bar chart and R bar chart. X bar chart and R bar chart. This is an X bar chart and R bar chart are plotted to know whether the system is in the statistical process control or not. And here we have taken the 8 plates and taken the 32 readings and then plotted the graph. Here it is both the things are within the limit, upper control limit and the lower control limit, and mean is the 524.5109. and here only the 1 point at the is out of the control limit. Only at the point 3 it fails, and all other points are within the specification. From the chart we can say that process is out of control only at 1.3 and all the points are within the specification. Coming to the conclusion part, the conclusion is that like the gauge R&R study we performed at MMD is acceptable and suitable, and SPC charts are also within the control limit and within the specification limit, and the process is also capable as the CP and CPK values is good. That shows the process is capable. Thank you.